Okay, good morning. Welcome to
FamilyMath number 1130.
1130. Okay, so yesterday we made this zonish. What do you call it? Zonish polyhedra.
Yeah. Didn't really have a specific name.
That was what George Hart called it, and we found out later that it was related to this shape, which is what?
It's called the icosidodecahedron.
It's an icosidodecahedron, and actually we connected up some of the inside points because we saw that we could do that, and it actually allowed us to find the center of the icosidodecahedron.
Yep.
So hopefully these show up well on the camera. I just never know. So what's similar about these shapes?
Well, some of the faces are the same. Looking at the icosidodecahedron, we have top and bottom pentagon, and then 2 layers of 5 pentagons, so you have 12 pentagons total. And then some triangles, we've got 5 on the top and 5 on the bottom, and then 5 around this middle layer here, and then 5 down here, so I think 20 triangles total.
Okay.
And I think if we looked at the numbers for this zonish shape, they should be the same. And this shape is related to this shape because you can take the faces on this and sort of blow them out, like start from the center and move them out a certain distance, and then connect them up using these red struts. And you get this shape.
Yeah, it's a really cool shape. Now, one thing that we're going to do for the second half of this project today is yesterday you said this shape, the zonish polyhedra, looked very spherical to you.
Yeah.
I'm not able to, right this minute, know how to calculate the volume of that shape. But the volume of the icosidodecahedron actually is known, and there's a very easy formula for it. So what do you think about how spherical the icosidodecahedron is?
I think it's less spherical than this shape because of it's a lot smaller than the shape, and the size of the pentagonal faces make it less spherical.
Less spherical, okay. Now, one of the reasons why I had us find the center here is actually it turns out there's a really nice relationship between the side length and the radius of the sphere that would go around it. So the distance from the center to the vertices is the radius of that sphere.
Yep.
Do you know, you might not remember, but do you know for Zoom tool what the ratio is of a long to a long medium, which is the radius?
I think it's the golden ratio.
Yeah, that's right. It's 1 plus square root of 5 over 2. So the side lengths here are 1, and the radius of the circumcircle is 1 plus square root of 5 over 2. So we actually can compare the volume of the icosidodecahedron to the volume of the sphere.
Okay.
And before we do that, what is your guess? If we drew a sphere through those outside points, how much of the volume of the sphere do you think the icosidodecahedron inside would take up? Just look at it and see if you can form a guess.
I'd say maybe 90% of the volume.
90%, okay. And what about for this one over here? But we don't know. We're not going to be able to figure out the answer to that. What would you think the answer was over here?
95%.
95%. So you think it's sort of, in some sense, twice as spherical?
Yes.
Okay. All right. We're going to go up and look at my computer, and we're going to look at the formulas and then do the calculation.